Okay, so in this lesson we're going to talk about statistical significance, something I've mentioned a lot, and that's because it's pretty important in any kind of scientific experiment. So what exactly is statistical significance, apart from a bit of a tongue twister? Well, in statistics, it's a concept used to provide justification for accepting or rejecting a given hypothesis, or more often than not, rejecting a null hypothesis. So our theory is usually in the kind of reverse, i.e. red buttons make no difference over blue buttons in a checkout, for example. So we seek to actually disprove that rather than prove that red buttons are better, because that implies that we perhaps think they are. So we basically have to determine that what evidence we have to make this conclusion is going to be good enough. There's going to be enough evidence to conclude that one thing is better than the other, and that we can reject a null hypothesis or accept it. We need to actually make sure that what we're observing isn't just due to chance. We can't sample everybody in the population. We can't get everyone to our page to click a button. What we're only ever doing is taking a sample from the population. So we need to make sure that we just didn't happen to stumble across a certain number of people who liked one thing more than another without it actually being better. And we do this by observing something known in modern statistics as a p-value. So the p-value is an index, and it's between 0 and 1, and it's a value which gives us a strength of the evidence. So the p-value kind of hinges around the 0.05 mark, which is the kind of area where we start to cross the boundary between rejecting and accepting the null hypothesis. So if we have a p-value of 0.01, we have a highly significant set of evidence to actually reject the null hypothesis. Between 0.05 and 0.01, we have a significant set of evidence to reject the null hypothesis. And around 0.05, well, it's marginal, and we'd have to kind of weigh up what we were going to decide and what we were going to put in our evaluation. Greater than 0.05, we can actually accept the null hypothesis. So we're not going to go into calculating the p-value. It's beyond the scope and interest of this course. It involves equations and lookup tables. But fortunately, people have created a set of tools online. So Visual Website Optimizer has a tool, HubSpot, and various other calculators are out there. If you Google them, you'll find all kinds of things. I particularly like the VWO one, the Visual Website Optimizer calculator. It's very clear and easy to use. So we feed it the control and the variation visitors and the number of conversions, and it will actually give us the p-value and tell us directly whether it's significant or not. So let's look at some examples. Okay, in this version, where the null hypothesis is the conversion rate of the red button will be the same as the blue button, we've had 600 visitors to the control A and 600 to the variation B. So 200 people have pressed the blue button and 250 have pressed the red button, difference of 50. Now that calculates with the sample size of 1200 through the online, the calculator, the tables and the equations that are going on in the background to 0.001, which is highly significant. So we can reject that null hypothesis. There is a conversion rate difference. In this example, we now have only 228 people who click and convert on the red button, and the p-value has shot up to 0.046. Now this is only a marginal significance, so it's just below the 0.05. But we can still reject the null hypothesis, although we're a little bit more undecided really, and we'd have to put our concerns in the evaluation. And in this example, we're down to 210 clicks of the red button, and the p-value has gone up considerably. It's now 0.271. And on that basis, with that sample size, we actually have to accept the null hypothesis that this isn't a significant difference, and so red buttons are the same as blue buttons. So what we're trying to achieve with this testing is avoiding type 1 and type 2 errors. A type 1 error is assuming that a relationship exists, but actually the evidence shows that it doesn't. So a researcher should accept a null hypothesis, but actually the opposite happens. A type 2 error is that assuming a relationship doesn't exist, but actually it does in the real world. So a researcher should reject the null hypothesis and accept the research hypothesis, but actually the opposite happens. So a more worrying problem is when the winning variation is actually wrong. And sometimes it's hard to know when your results are telling you what you actually think. So you think something's had an impact and you've proven that it does, but actually things further down the path, the funnel, aren't happening. So your red button might get people to the checkout, but then for some reason further down, maybe right at the last stage, they're not completing the checkout. They're not actually putting their credit card details in. So we actually have to look at why that's happening. So we can't just take that the red button leads to better e-commerce performance, because that isn't actually what's happening. It's type 1 error basically. We think there's a link, but in fact there isn't. So how do we turn things around? Well, we have to keep track of those next steps, not just the red blue button kind of area. We need to keep track of what happens beyond that and make sure that we're actually monitoring people leaving pages in those subsequent steps, so we can try and determine why they're leaving the flow, the funnel. And we can perhaps only really do that by talking to them, by doing user testing and interviews, and actually trying to tease out these ideas that might be kind of quite tricky areas of psychology, like what made you think that this wasn't safe at this point, or what put you off at that point. But we need to explore these things further. Okay, so in the next area, we're going to assume now we've got a certain level of expertise, and we're going to just take things a little bit further.